Comprehension. When a force F is applied on a block of mass m resting on a horizontal surface, then there are two possibilities. Either the block moves by translation or it moves by toppling. If the surface is smooth, then the block always translates, but on a rough surface, it topples only when the torque of the applied force F is greater than the torque of mg about a point in contact with the ground. When the force F is applied by the body may topple about A or it may translate. So this is the picture. This is the body of width A, height is h. This is point A. Force F is applied at the top about point A. Now question 1. When the block topples about point A, the normal force passes through the center of mass is 0, shifts to the right and passes through rightmost edge containing A is 0 if the surface is smooth. So we have to calculate about the normal force. Let us consider this is the surface. A body is placed on the surface. What are the forces acting on the body? One is the force which is applied on the body. This force is F. mg act from the center. Friction force will be there between the two surfaces. This is the friction force. Now about point A, as the block is going to topple, then this is the axis of rotation. The normal reaction shifts from here to this particular position. This is N. One point we should note, when the block is on the verge of toppling, force diagram on the block is as shown here in the figure. The normal reaction will shift to the point of contact about which the block topples. So normal reaction will shift about point A. One more point note, block will slide if this capital F is greater than the limiting value of friction force, and that is equal to mu mg. And the block will topple about point A, condition if torque of force F about A is greater than torque of mg. That means what is the torque about this point? Force into perpendicular distance. This distance is A, this height h is also equal to A. So when I apply a force F here, the torque of the force F will be F dot A. This should be greater than torque due to mg about this point. mg into perpendicular distance will be A by 2. So mg into A by 2. So F should be greater than 0.5 times of mg. So if I take this as equation 1, this is our equation 2. Now here it is given mu value as 0.2 in the second question, and in another third question value of mu is given as 0.6. Let us estimate with the two values. Now if mu is equal to 0.2, condition of sliding will be capital F is greater than 0.2 times of mg, while condition of toppling is still F greater than 0.5 mg. So what do you get? So it will slide before it topples. Now if mu is equal to 0.6, again check, condition of sliding will be F greater than 0.6 mg. Condition of toppling is F greater than 0.5 mg. So the block will topple before it slides. So it will topple before it slides. So now let us look into what are the answers for the various questions what we have seen now. The first one, when the block topples about A, the normal force passed through the center of mass is 0, shifts to the right and passes through rightmost edge containing A is 0 if the smooth surface is smooth. So where we got? We got the normal reaction about point A to be somewhere here. So it shifts to the right and passes through the rightmost edge containing A. So option C is right. A option passes through center of mass is wrong. Is 0 is wrong. Is 0 if the smooth surface is smooth. This is also wrong.